All right, so in this video, we're going to introduce the idea of free fall. Okay, and free fall, there's really nothing new about free fall. It's simply a application to constant accelerated motion. So we're still in kinematics. The only difference here is whenever we have a free fall problem, we automatically know what the acceleration is going to be, even though it's not stated clearly in the problem. So let's first define the idea of free fall. And free fall is basically motion that is only influenced by gravity. Okay. Now, technically speaking, anything falling is under the influence of gravity, but in the real world, you've got things like air resistance and other things that can interfere with that fall. So, free fall is when it's falling only in gravity, in a place of what we call a vacuum. So, if we want to, well, let me first define a vacuum for those that don't know what that means in terms of physics. So, a vacuum is space without anything in it. Okay, so outer space is probably the closest thing we have to a naturally occurring vacuum. We can create them in labs and kind of in experiments for stuff, but a vacuum is something where there's nothing in the system that can influence. So in a vacuum, for example, there's no air. So air resistance would not be a thing. Okay, so what we would define by free fall then is in a vacuum, okay, an object falls, so we'll say the acceleration due to gravity is, we'll denote it with the letter G for acceleration due to gravity, has a magnitude of 9.8 meters per second squared. So an object falling, okay, if we do a quick little diagram of this, an object that falls, so it starts with a velocity of 0. Now let's say that each tick mark represents 1 second. So this would be at 0 seconds, 1 second, and at 1 second you would then have a speed of 9.8 meters per second. Okay, the next second, so at 2 seconds, you would have a speed of 19.6 meters per second. And further down, you would have a speed of whatever another 9 would be. So that is 29, no, is it 29? Let's see, 4, yeah, 29.4 meters per second. Okay, so, and you can see that the difference here is a 9.8 meters per second for each interval. Because again, acceleration would mean that you're looking at the change in velocity per time, and if the velocity is changing by 9.8 meters per second each time, then, or for each second, then the magnitude of the acceleration will be 9.8 meters per second squared. So this is representative of what we call free fall acceleration. So for the time being, we're only going to deal in cases where there is no outside influence, and we will get into more details for that later. Okay, so let's look at a couple ideas for free fall. All right, so the first, let's look at a motion graph. So we'll draw a picture first. Imagine somebody who's standing on the ground, and they take a ball, and they throw it upwards. So they give it some initial speed. Now, we know the ball is going to go up and then come back down, okay? And that means that for one direction, we have a positive velocity, and in the other direction, we have a negative velocity. In fact, if we were to graph this motion, so velocity at a time, okay, it would start, our graph would start up here with some initial velocity, because it starts positive. Okay, now what should this graph look like? Well, since there's nothing acting on the ball, the only acceleration is gravity downwards, or the acceleration due to gravity downwards. So that means our acceleration here should have a constant slope. Because if the acceleration is constant, we have a constant slope. So I start at my positive velocity v. I draw a straight line downward. Okay, now what's important here is you'll notice we crossed the t-axis. Now, by this point, we know what that means in terms of explaining the numbers. Above the t-axis, you have positive velocity, positive direction, and below the axis, you have negative velocity, meaning negative direction. So this should make sense. As the object is moving up, its velocity is slowing down. Then it reaches this point at the top, which we call the max height. And after it hits max height, it turns around and goes back the other way. So it starts to speed up in the negative direction. So my velocity numbers get bigger in the negative direction. Okay, and at the point where it's max height, that's where it turns around. So on our graph, that represents the point right here. So an important concept to that is the velocity at the max height is always 0. Because when it gets to the highest point, it stops and then it turns around. Okay, so that's kind of the basic idea of something we'd see in free fall on a graph. Okay, now let's talk about it in terms of a problem. So we'll do the same picture. And in this case, let's ask, what is the max height that this person's, when he throws the ball up, what it reaches? So what we're going to do is we'll draw the person again, and he's got the ball, and he throws it upward, and we want to know what is the max height. And we'll say that he threw it in the air with an initial velocity of, we'll make it easy. We'll say he threw it up at 19 meters per second. So, if we're going to kinematic problem here, we're trying to solve for whatever the change in height is. So rather than x, I'm going to start using y's, right? And reason being, if you've got x-axis variables and y-axis variables, we're moving up the y-axis. So I'm going to refer to this as a y variable. Okay, so when I list out my variables, I've got y0, y1, v initial, v1, acceleration, and time. So y initial, we'll just say it starts, we'll simplify it, we'll say it starts at the ground. Okay, then it achieves a max height of an unknown value. It starts with a velocity of 19 meters per second. When it reaches the highest point, it stops. And the acceleration is free fall, so it's 9.8 meters per second squared. Now the only thing we want to be careful about here is which direction is this acceleration. So since the acceleration is pointed downward, we're going to put a negative sign on that acceleration. And we don't know anything about time. Okay, so we're solving for y. Since we don't know anything about t, we can use the v squared equation. So we've got v squared equals the initial velocity squared plus 2 times the acceleration times the change in y. Now we've used this equation before, so I'm going to skip the algebra steps to get to the change in y. Okay, let's plug in our numbers. So we've got 0 minus 19 squared all over 2 times negative 9.8. Okay, so if we crunch this out, you're going to get 18.4 meters. So that would be the maximum height of this object. Okay, and so that's it with free fall. It is going to be a short video because it's mainly a conceptual thing. It's to understand that when you have an object in free fall, the only acceleration is gravity, and it's downwards. So you want to make sure when you put it in your list of variables that the acceleration is negative 9.8. The other important concept from here for free fall is whenever an object's moving up first, it's going to stop, right? Acceleration is slowing it down until it reaches the highest point. So that concept of the max height being zero, or the velocity being zero at the max height, is also very important.